Okay, hello. Today is October 8th, 2024. This is SIG Node weekly meeting. Welcome, everybody. We have a few items on agenda, and first item is mine. I sent it, mail yesterday regarding containerd. It started worrying me, all this containerd implementation. Like we are very diligent on CRI API, on other APIs, and we were demanding some implementations. For CRI API, historically, we've been also asking for implementation in the real world um, validation of features. And historically, it was reasonably in sync. Like we had at least CRI and containerd shipping feature all together, and containerd and CRI was adopted reasonably fast, so we got enough validation reasonably quickly, so we can progress caps through stages. Now we have very strange situation with containerd 2.0, which was planned for to be released 1 year ago, and then half a year ago, and like now we still haven't unblocked everything. And I mean, it happens. Like nothing extraordinary. Just I mean, maybe not enough contributions. I don't know, like what happened, but
2.0 is a unique circumstance. Once we get through it, we're there pretty much now. I'm pretty sure we could do a 2.0 and then have a 2.1 follow up. And this the cycles will come quicker. The releases will come faster after 2.0. It was a major change.
yeah,
Config, migration, everything, right? New API, direct pass. Yeah, a lot of work had to go into it.
yeah. But the situation today is that containerd 2.0, even if it's released like at KubeCon, as Dims replied, we will still have some time for people to adopt it because it has lots of breaking changes. So at least another half a year, I would say, very optimistically. Um, and people will wait for Service Pack 2, 2.2 maybe.
2.1 at least, yes.
Yeah, so we're talking about
But there'll
another.
be, there'll be a bunch of, minor refreshes too. So
Yeah. So my question, and we never wrote down any official policies, like whether we want to promote caps to beta if it's not validated on like containerd or something like that.
I think it depends, right? It depends on the feature. If it's a feature that is natural only for cryo, then that's fine. Like the split file system, right? Where we can have a split for per snapshot, or it doesn't that doesn't fit well with cryo either, right? And that's fine, I think, for that one. For the OCI volumes, I would say yes. Before that goes beta, you want to get the containerd one out first because there's some differences in the implementation. I don't think we had enough details in the original cap, and we're ironing that out now.
Yeah. And this interesting aspect here is like even in 2.0, we wouldn't have OCI volume images, maybe 2.1. Um,
Oh no, it'll be there.
it'll
We've
be
got a working PR and it's being tested right now against end-to-end.
okay. And yeah, Sam said that split file system could fit into model. So yeah, I think what I'm looking for is some clear whether we can come up with some policy on how do we promote caps based on how many container runtime supported it, and like whether it's battle tested in production or not. And today we are at this unique stage. If we saying that caps needs in order for cap to go to beta, you need to get production deployments on 2 runtimes. I mean popular runtimes. Then we kind of delaying for another year. So we have like uh, at least half a year for adopt 2.0, and then only that we will have some adoption, and we will see some feedback from customers. If we're saying that, then like we delaying at least 2 caps right now. I think in place may be fine if it wouldn't require any changes in run CRI in place pod update, but everything like at least 2, like we see volume images and supplemental group are now in this strange situation. Not talking about caps that already in beta, despite that 2.0 wasn't even available. Yeah, hands.
Real quick, I just want to, I chimed in on the email thread. I feel like I don't love the pattern of needing to wait for both runtimes to like move forward with a feature in Cube. Like, I think part of the CRI is that it is pluggable, and the kubelet should be resilient to like features not being present in the CRI and still be able to like, you know, move forward. Like whether or not the pod actually gets created, probably usually it should not get created if the feature isn't supported. But, you know, we have like infrastructure now to be able to tell when a CRI implementation supports something, and that's even reported up through the node object. So now like you could actually have a scheduler be able to tell when a node is supporting it, and you could have a plugin that would, you know, move workloads to you know, nodes that maybe have a newer CRI implementation or a different one. I mean, and this is partially with my cryo maintainer hat on, like part of like the one of the reasons that, you know, we've been sticking with cryo is because like we're able to tie our, you know, life cycle to the releases of Kubernetes. So like that's part of our value proposition. And so like obviously you know, love working with Containerd, and it's definitely good that we have both of them. And also, if we perpetually delay like features in Kubernetes, waiting for both runtimes to support them, then I think that sort of dilutes the proposition of having individual runtimes in the first place.
Dawn, do you want to go next, or do you want to discuss what?
Yeah, I can go next. So, I muted. Oh, I already have mute. Can you hear me? Oh, yeah, it's cool. So, thanks, Sergey, to bring this one. I agree with you. We need really, it's new time for us to discuss this one, because many years ago we did decided, right? So like the CLI layer, we define, we even start several tests, only test on the CLI layer. But over time, we have like continually donate to the CNCF and also others cryo donate to CNCF. And we have the pre-submit test blockers endorsed container runtime. So we are kind of like the relax a lot of those kind of the CLI layer of the test, all those kind of things. So, and also I totally say what Peter say, because that's when we first Red Hat approached me, say, oh, we also want to invest our own container runtime. Of course, there's the business reason behind, but I also have the community one. The Containerd is one of the community one, right? So that's why we have to define this to see what's the community, what general things. But I totally agree. We keep blocked by the release, like the Containerd 2.0, have the example, like the several feature also blocked by that one. And SIG Node have to carry a lot of compatibility and the not compatibility, all those kind of things. That's also, we need to figure out what's the boundary. And I think once we figure out the boundary, that's also help Containerd community how to prioritize, because we don't have those signals, right? So they basically also don't know what kind of is what we must have, what we can relax. So let's just working on, this is our like, community, like the next item besides the individual features. Yeah.
You make a great point, Dawn, and sort of Peter. On the Containerd side, if we were told this is critical, we're modifying the pod spec, you won't be able to run these pods that have these volumes in it, and that we're gonna get that in, right? And we're gonna ship 2.0 to make sure it happens, or we're gonna backfit that to 1.7, right? We're gonna make it happen. We're not gonna break that relationship that we have with Kubernetes. Okay, so I think it does depend on the feature, right? If it's a must-have pod spec item in order to be compatible across the various runtimes, then I think we need both, and we need, you know, to get in gear if we're behind something. I'm sure we're ahead of, you know, cryo on some things, maybe, but not necessarily the SIG node features. So we need to make that happen. And right, but Peter's also very correct here. We may not backfit these to older runtimes, and we need to make sure that that's still okay. Version 1.7, 1.6 are in production, and you may only want to update your Kubernetes, not the runtime, and that's perfectly fine with us and the way we've been going. So we need to make sure, as Peter said, that these features don't have that kind of, it can work with or without if it's a change. So I think we're going to have to make a decision point. The serialization feature, I mean, that one could have gone without containerd. That one probably is okay. We've already got a way to test it in main, but it doesn't, I don't think that's the kind of feature that is a required feature for Kubernetes, not to be cross, runtime compatible, right? Maybe I'm wrong. Go ahead, Peter.
I think something like that I find myself sort of likening it to, like in Kubernetes, we don't block on features advancing in their life cycle if they require newer kernel features. We just expect that the kubelet detects that the kernel features are there, and if it's there, then you use it. If not, then you don't, and you fail, and you have an error that is reported well to the user. I really think that the CRI should be treated the same way, and that's kind of my broader point. Regardless of what the sort of negotiation of oh, is this going to get pulled back to 1.7 or is this going to stay in 2.0? When is 2.0 going to come? Ultimately, Kubernetes, the kubelet as a project should be resilient to the underlying pieces that it relies on, not actually having features that it may want to use. And I don't think that we should slow down the process of kubelet features to make sure that every LTS Ubuntu also supports newer kernel features in the same way as I don't think we should do the same for containerd. And that's, I think, my broader point. I think Kevin was next, and then Daniel.
Yeah, I guess what I'm hearing is from the SIG node side for new keps, I'll add one other case in here as we need to think about cgroups v1 and v2 support. And then we also have, I know we're phasing out cgroups v2, we still have to make sure stuff works on v1. And we also have whether or not it actually is required for multiple container runtimes. I'm wondering if we should maybe have a SIG node specific section in the PRR to kind of call this out in reviews, to kind of help make that call about whether or not this is actually required to have both container runtimes. Because otherwise, we're gonna forget in 6 months from now on the KEP process about, is this required for containerd or cryo? Because I do agree with you. Pod specs, I think it probably should be required for both. For a split file system, that is not a pod spec feature. And it's not really clear to me. I think we could go forward with one because the users of containerd can choose not to split the file system, but still, I think we need at least some kind of statement in the KEP process that at least makes it clear about what the graduation process for this feature which should be, and we can add a section to each KEP. But it was kind of something I was wondering about.
Sam, what's next?
Thanks. Peter, I agree with what you're talking about, where the CRI should be gracefully degrading, or the kubelet should be gracefully degrading based on the presence of a container runtime actually supporting a feature or not. I think that makes a lot of sense. The concern that I have, and I don't know if this is precisely the same concern that Sergey has, but it was my interpretation of what he was saying, is if we're having a KEP and we're saying, hey, this is a KEP that's ready to go to alpha or ready to go to beta, and we want users to actually test it, we want to know that that's going to be something that both runtimes or any CRI runtime could actually support, versus it just being something that is implemented in one. I don't know that we have really that concern about any of the ones that we're talking about today. They all seem relatively supportable by both cryo and containerd, whether or not containerd actually has support for them today. But sort of at a philosophical perspective, I don't know if we want to formalize a Kubernetes feature that can't be implemented by, more than one runtime.
Yeah, I mean, and I'm happy to, like, I'm fine gating a feature. I mean, I would probably even gate that at alpha if there's a feature that we're like proposing that like philosophically doesn't work with one of the runtimes and like we don't want to do it, then like I'm happy to sort of be stricter about that. But like I think I think if I were to summarize my position, I don't think we should block KEPs from going to beta that rely specifically on, like, I don't think we should block those KEPs from moving to beta on both runtimes. I think having one major runtime, having support for a feature, as long as the kubelet can gracefully degrade, assuming that eventually the other runtime expects to either be able to support it, or we have infrastructure in place to protect users from assuming that they're like it's going to be supported and it won't be. So like whether that be a scheduling plugin or like, you know, like metrics on the kubelet that say like, hey, you're using cryo and this is never going to work that way. But I'm not as worried about like that case, Samuel, because like I think at the enhancement stage, we are pretty good about working together and being like, okay, this is something that we're like gonna work on eventually. We just have different timelines and when that's gonna happen. And my priority is not slowing down the Kubernetes timeline, which is already quite a long process to get a feature in, on like, you know, from my perspective, a project that I don't really work on, you know, and like the point of the CRI is I don't need to. So decoupling the lifecycle of the Kubernetes feature from the CRI, as long as like someone can use it in production somewhere, I think that should be the criteria for beta. GA, I'm happy to negotiate, and I'm happy to sort of maybe say both of them need it or something like that. But I think beta is kind of where I think at least one should be the requirement.
I mean, realistically, if you're talking about promoting KEPs into beta, like we're talking about enabling it by default, and what the degradation in most cases will be is pod admission rejection. So we cannot, like, unless we build like very sophisticated way to propagate all the CRI API limitations all the way to API server and reject pod on admission on API server, like having some webhooks that knows about all the CRI versions across all the nodes, or like even on scheduler, like scheduler will schedule based on CRI versions. I don't think we're up to building that. And if you're not building that realistically, user experience will be very degraded. Like they try to use new feature, it's enabled by default. And we saw it with the user namespaces. Like people try and user namespace and they like cannot make it work on container even though it's like 1.7, but it's not like correct version of 1.7, and like it was not very pleasant experience. And we had like much feedback on community to like why it's not working. Like we have few bugs filed. So I wonder, like, I mean, when you're talking about graceful degradation, I just don't feel that we have graceful enough degradation built in on Kubernetes to protect our users from that on a community. Plus, like, for beta, stability is important, and I wonder like how much stability we can guarantee if only one runtime supported, and then another runtime trying to support, and suddenly we need like change API fields or like change we started like deprecating all the APIs field, beta API fields, because we realized that it wasn't designed correctly, and we need more information to be propagated.
Yeah, I think my point is more that like now with the node, the runtime handler features and the runtime features field in the node info that the kubelet is reporting and drawing from the CRI or the OCI runtime through the CRI, we like users can have that additional, like, not that we as like the Kubernetes project are committing to making scheduler plugins or admission like plugins that'll actually, you know, take that information into account. It's just information that is readily available that they don't have to sort of like muck around on the nodes to get. So I think I understand your point about the feature, like the expectation that like, oh, if a feature is in beta, then I should be able to use it practically everywhere. But like, that hasn't really been, I mean, obviously using namespaces is off by default. So it's not even, it's less relevant for my point in this situation, but like my point about the kernel feature, you know, relying on ID map mounts, that's like a new enough feature that a lot of LTS supported operating systems don't have it yet. And, or it needed to be backported for. And, like, I don't think that that should have slowed it down from moving it to beta. It didn't, obviously. And that's kind of my broader point.
I mean, kernel example is not fair because at some point all the LTS will update to the right kernel version, and I mean, there is some commonality that will be bumped to the proper version at some point, and everything will support it. In container runtimes, if you're advocating for features that are consistent, like forever single runtime only, then we need to build infrastructure for that.
Well, but I'm not advocating for forever single runtime. I'm advocating for beta shouldn't be the point at which we gate whether or not both of the projects support it. I think it should be something later like GA. Like, I think, and I guess, so I hear you on the point about the kernel differences, because eventually the kernels will update. What about Windows versus Linux support? There are a bunch of features that we just straight up never intend on doing in Windows, and that doesn't prevent us from moving forward on Linux, and vice versa. But the kubelet is smart enough to be able to say, like, hey, this is actually a Linux-only feature. You can't use this. We'll go all the way to GA with something like that. I don't see a reason why it wouldn't sort of be treated similarly, where we're just, you know, we can provide ways that admins can like read into this information so that they, you know, get something a little bit earlier than admission, and that'd be great. But ultimately, like, I don't think promising compatibility on all nodes for like every feature is feasible.
Since you mentioned, sorry. Since you mentioned Windows, then I want to argue, provide a little bit of counter argument. Windows, it is incremental feature we added, we introduced to Kubernetes. From day one, we didn't expect it, we are support Windows, right? So then we want to expand it to support more workload and more different operating systems. So then we included of the Windows, because of course, there's the demand. Everyone want to, so it's different from the CI. In the history, we did waiting after we choose three runtime, even include of the VM based off the runtime. So we did carefully say container runtime interface features will be blocked by the CRI and the containerd. We did wait for CRI before, but we also say that, and even when VM based off the container runtime, it is the start from beginning, but we don't want to, because its VM is different, so we are not blocked. So this is why there's the history where we block by those things. So in the initially, actually, containerd go faster, have more features. So we did wait for the CRI to some extent. So that's why we need to re-examine this whole thing. Situation changed. I totally understand that we try to balance about accelerate of the feature, right? So then once we accelerate a feature, then we can get more feedback. But there also have the things, it is because while it is bounded by the operating system, right? So then the feedback will be single set of the feedback. And we might miss some of the inputs from the containerd user. So that's why how to balance those kind of things is a little bit challenging for us, but I totally understand where they came from. So anyway, just wanted to provide those contexts.
Yeah, and I think part of my position is informed also by waiting for a really long time on CRI stats to be supported in containerd. So this is like a difficulty from the perspective of the crowd community, because we've had support for a feature for a long time and have been sort of advocating like, hey, this would actually be materially really good for us. Like, it'd be very useful. And it's been sort of stalled because it's just not a priority for containerd. And that's fine. But like, as we sort of move forward as a project, like, what is like, at what point do we continue to gate features that just like, you know, like the cryo community shouldn't have to like really urge the containerd community to do something if it's just not important to them. They can do it eventually because it could be important to them in the future, but, and like, you know, happy to help. And theoretically it's being worked on now, but like, you know, I think the same would go for the containerd community. If you had a feature that was a huge priority for you and it wasn't a priority for cryo, I don't think anyone from them would want to come and work on it in cryo. I don't think that that should slow down the feature generally, as long as we can gracefully handle it when it's not present.
Yeah, very interesting discussion. I don't know, I still don't know how to write the policy. What do we do with the current two caps? Like we have OCI volume source and supplemental groups. Do we promote them to beta or we wait for 2.0 confirmation?
My understanding was, I think it's okay to promote them to beta. Like I thought it was always the beta to stable is where we were unclear on.
I think this conversation started, I think Sergey has been posing it as like beta is the level that we require both runtimes to have support for it. And I'm pushing against that. So I think that that is the like keystone conversation we're having. So my position, I think that promoting to beta with one runtime supporting it, and users having expressed that they're using it and they're like it's working for them, I think that that's like that qualifies for beta. I don't think it would qualify for GA, and so that's a separate conversation. But for these two caps, I would say like cryo supporting them should be sufficient. But that's
Yeah, I really worried about customer experience when they try OCI volume source and like nothing works, and realistically there is not much they can do. So I mean, one middle ground may be beta by disabled by default, and you cannot enable by default unless there are two container runtimes. There's maybe another middle ground. And I just don't know how much middle ground we need and how much we just need to make sure that containerd is stuffed enough to follow the to implement features fast enough.
I mean,
I'm
I
happy
think no
with
matter
the middle ground to begin with.
There's not just like the enable by default, right? So I agree with you, Sergey, because today new policies beta is enabled by default. Not just that, also once you beta stage, you normally like the API cannot change. That's the challenge part for us, because in the old time, like the even beta, we can allow the API change, and until the GA, you cannot change the API. But the new trend actually also for accelerate of the process, and we allow like we try to make sure like the beta, once you get to the beta and the API cannot change. So once you have that one, you are missing a lot of the inputs from another container runtime and maybe trigger off some API changes. So this is why people have the concern here, right? It's not like the default on or default on also is another matters, but it's at least the mechanism we can switch off. But the API part actually is more challenging.
Yeah, that definitely that's a tricky part. I think it's tough because like because the priorities of containerd and cryo can be different, like the timelines can be really pushed out. So like at what point do we say this API has existed long enough that we qualify it as like good enough to move forward with? And I don't know. I think that'll be really tricky to sort of define. And because of that, I think it's tricky to sort of set the expectation that both of them have to support it or +1 on it before moving forward. I think that's tough. I would expect in this process, in the ideal world, at the alpha or like the alpha to beta transition, both of the runtimes are like, this API looks like it could work. We have maybe an example implementation, or like, you know, we have enough information to say like, this is good enough to move forward with. And that would be enough rather than needing it to be in like some stable release. Like for the forensics container, use case, the checkpointing, it's not in, like 2.0 isn't out yet, but the PR is merged in container D. So that like, and granted it is already in beta, so that already happened, but you know, maybe that could be like having a PR in container D or having, I don't know. It's like having some sort of like +1 from both communities saying like, this API from my perspective looks safe for like the project that I represent. Maybe that could be the gate. Iris?
Yeah, I've raised my hand just to ask something. Perhaps it's a naive question, but why we have two container runtimes different? I think the answer is because they see different things and they want to add new features, I guess, correct? So how does this impact?
There's a lot of history basically, but at the end of the day, we've kept them because like from my understanding, both of the container runtimes have different sort of lifecycle expectations and different client integrations. So Cryo only focuses on Kubernetes, so its lifecycle is only tied to Kubernetes. Container D has a lot of other clients, and so it has a different sort of lifecycle, and like you get different advantages from either, and that's basically what people choose when they're choosing which runtime.
Also a plurality of CRI clients. So
Sharon?
Yeah, hey folks. So this might be a super noob question, but I was curious about how the release cycles of these container runtimes and like how they're related to Kubernetes. So I'd been playing around with the issue, like a really old issue for adding stop signal to the container spec, and I was talking to Akhil about it. So as I understand, if I edit so there is a stop container method somewhere in the kubelet runtime. And if I edit the signature of that method, like basically I have to update the CRI API, and I would also have to, so currently the stop container method takes like container ID and like timeout or something like that. So if I change this signature, I'll have to edit it across the different container runtimes until I will be able to use them to run Kubernetes with these container runtimes. So Akhil mentioned that we have something called unimplemented, like something that returns that the method is unimplemented in a particular container runtime. So like if my feature, let's say, is going into alpha, does it mean that it has to be available in like at least one container runtime, or like how does that work, and how?
Not yet.
Yeah.
Yeah, that's a great question. So typically alpha, so to merge something into alpha means that like there isn't yet CRI support. So typically what we do is we like say, like, you know, you can merge it in alpha and it's not yet in either of the CRI implementations. Then, you know, then you vendor basically the CRI change from the CRI API into one or both of the projects. And then that vendor bump then can use the new feature. And any gRPC is smart enough to be able to say like, oh, I don't know what this is, so I'm not going to send it with the different versions of the protocol. So some of the like handling of whether or not it's supported happens under the hood, but yeah, so you don't need to have the container runtime supporting the CRI before you have the feature merge, because it's kind of a chicken and egg problem. Like you can't have in the past we did like CRI change, then get it into the CRI, and then actually have the kubelet use the CRI change. But at this point, we sort of ended up coupling them and then just having the CRI catch up after alpha.
Yeah, I posted a link to a README on CRI APIs that describes this process.
So, thanks, folks.
So what do we do with these two caps, like OCI volume source and supplemental groups? Supplemental groups is implemented in 2.0, and I don't think there is a concern that it wouldn't be working as API, but concern is like whether it's working as whether it's validated on production. And we I mean, it may be fine to merge, like promote this to beta, but again, confusion will be when customers try to use this feature and it doesn't work, and it will be. I mean, degradation will be graceful enough, but like not that graceful. It will be not ideal for customers.
Yeah.
We're
Yeah, I
close
mean,
to
I
the
think-
merge.
William, sorry.
We've got a couple of questions. You know, we'd like to talk about this one, the OCI volume. It might be a longer call. Do you want to discuss the issues? I mean, we don't have artifacts in yet, right? And I don't think that's being attempted to be supported. It's just the OCI image. I don't know if you wanted to go to beta on just images. If so, then fine. But we also, there's a question of what is the life cycle of this volume? Is this supposed to be shared across pods as far as having, you know, the image localized and then, you know, we would keep a lease? Or do we expect there to be an instance of the image per pod such that if you were to delete everything that that pod owns, then the image would can be then collected? I think there's a little bit of a question there. That's the last thing we're running into on before it's getting merged, is the question of whether or not we should be sharing the OCI volume image for the pod that's being mounted to the containers, whether we should share that image across all of the pods in the runtime, or per disk.
I would say for succinctness for this meeting, I'd say maybe we talk about that offline, but I can see those problems. I think to like sort of unblock enhancement freeze, what if we say off by default, betas are allowed if only one CRI implementation has it implemented, as long as the other CRI implementation comes in and says, this API looks good to me, I don't think I'll need any changes for it. Does that seem fair?
That does seem fair. Give us the opportunity to question the march to beta, because don't want to change the API once we go to beta, right? That would be that.
Yeah, but I think what Mike mentioned, it's also sounds interesting from a user perspective. So I think if there are such corner cases, which in my views as an end user, questions are good because means that people are digging into it. So I would expect if
I
Cryo already have solved these questions, for example, as an end user, I'm speaking now, I would, I think it's important for SIG Node to know if there are answers. So, I mean, the proposal to take it offline, in my view,
Right.
it is.
I just meant.
It's not. Yeah, you understand what I mean. Yeah.
Yeah, and I don't think OCI volume is an outlier because it's a brand new API that was only introduced, you know, proposed a few months back. It's not like the other ones, like the stats API that we just haven't implemented in detail, and we've assigned people and just haven't had the interest. That's probably one that needed to go without our blessing, if you will, right? So I still think it depends. But yeah. Yeah,
and I didn't mean to take it offline to sort of keep people out of the know. I just wanted to make sure we got time to get through the other pieces in the agenda, but I'm happy to talk about it in whatever forum feels appropriate to anyone, and we can negotiate that. But I just want to make sure that we get to a couple of other things that we have. But we could also loop back to that if we get through these things, maybe.
Okay, we can discuss these two caps in PR description, PRs, in enhancements. And with regards to policy, we can iterate. Maybe I can start a document and we can iterate on this document. Okay, let's go to the next item on agenda. Francesca.
Hello, yeah, that's me. So, very, very short. So, a question for the SIG. We have an issue which is very targeted, meaning it affects a very well-defined and small subset of users, but from those users, it's a real pain, and it's a long-standing issue. Why it's long-standing? Because the fix could involve everyone else. And we are not really sure about how the proper fix will look like because it's a code very hard to test, quite old. So while I acknowledge that we should keep improving our tests, of course, we would like to make progress because, again, very small set of users, but quite some pain from them. So this seems to me quite a good use case for a feature gate covering a fix. Now, my take is that even if we go down that route, feature gate for fixes should be using very sparingly. But given also the recent and not so recent history of the SIG, that would be like fit still the case. So what's the take of the SIG about possibly using a feature gate to gate this fix once in a long while?
Francesca, my comment not about a feature gate, but an overall about this feature. If we are talking about this CFS quota settings, right?
Yes, it's a bug. Well, yes, it's an issue because people feel they believe. But yeah, go on, please.
It's not a bug. It's just like it's not effective if you have exclusive allocation. So my thinking is what it can be added as an option for a static policy, because this field should not be set only and only in the case when the static policy is active and only when the exclusive CPUs are allocated for the container. In all other scenarios, it should be still propagating down to the CRI because it uses the shared CPU set with something else.
My only concern to that proposal would be that the policy option will not be effective because my understanding is we will need to touch some piece of the code outside the CPU manager. So the flow is not only contained in CPU manager. That's the only concern I have.
I understand that, but that's how to minimize the impact for other scenarios when there is no like exclusive CPU allocated. So we need to pass a bit more information from CPU manager to the rest of the code.
That is an interesting option.
The reason why I'm saying is because the original issue was saying like, well, if this container is just guaranteed, then let's not put anything, and that's not correct.
Okay. Okay, that's an interesting take. That's an interesting take. Opens new ways to solve it. Yeah, that's true. Thank you.
Oh, my turn. So actually the Francisco, I already voted yes on this one because I feel this, I was surprisingly, we still didn't address this problem. I think a couple of years ago, we already have this problem and then we disabled, then we enable again, and then people have to run into the issue again. So to stop bleeding edge, and I'm okay with temporarily using feature gate. And I also understand, Alexandra, what you are talking about, but to build that into the policy take time. So that's why I think about we could, before we properly defined and understand of the policy, we can have some solution for people to stop bleeding edge, right? And in their production and introduce of the feature gate for temporary, and then graduate and retire of that feature gate later once we have to figure out a better policy to build into the CPU management and all those kind of other things.
But for any option in the static policy, anyway, we are doing with a feature gate. As I said, like I'm not against the feature gate. I'm just saying, but this thing should be done only when we have definitely exclusive CPU allocated. That's it.
Yeah, I guess my main concern with using a feature gate is like, what's the goal of, do we want to eventually drop the feature gate and then that would impact everyone again? Like, I don't think we want to leave feature gates on perpetually.
Yeah. Sorry, I should have elaborated that. The proposal would be guard the fix with the feature gate, and basically when we are confident the fix is fixing, move along with the feature gate. So start disabled. Okay, we are actually start enabled because we want to merge a good fix. So start with the feature gate enabled, but if some some people for their use case they see a regression. Okay, we have the option to disable it and restore the same behavior, and then fix that again, rinse and repeat, and hopefully we'll converge soon enough and have a good fix. But give the people the option to turn it off because it's a hard fix to make, and then remove the feature gate and lock to on and move on.
Okay. No, that makes sense.
Okay. That's any other question or comments?
So action items, you will explore what Alexander suggested, and then I mean,
Yes.
I have no problem.
Oh, okay,
So
absolutely.
Francisco, you are going to be the owner or identify the owner to move this forward.
I am reviewing 2 concurrent PRs to which want to fix this issue, and I will coordinate and report to the SIG. Of course, I will. Yes.
Okay, thank you.
No problem. Thank you.
Okay, next is Eddie.
Yes, hey team. I did request to see if I could share screen to go over a few things, but it's okay if that's not possible. Basically,
No, they can share.
Okay, awesome. Yeah. So hopefully everybody can see my screen. But yeah, I added this to the agenda. Basically, we're working on a CAP to address an issue that does involve SIG Node. There's quite a few SIGs involved, actually, API machinery, SIG storage, and so on. And we'd love to get your input on this. I know we're kind of short on time, but I did want to kind of go over the problem that we're trying to address. So as you folks know, as part of CSI driver plugin registration, Kubelet will call the corresponding CSI driver's node get info endpoint to retrieve the attachment capacity or limit for that node, and then a CSI node object gets populated with that attribute. Now, unfortunately, this attribute is immutable today, so this only gets set once during plugin registration. And so it's actually quite common for this value to not reflect the actual state of the world. So for example, if cluster operators attach out-of-band volumes, or in certain cloud providers, it's possible as users scale up their workloads for network interfaces to be dynamically attached, which also take up attachment slots, right? Suddenly this value is not accurate anymore. And when assigning stateful pods to nodes, the scheduler utilizes this value to see if there is capacity to support the attachment, right, before scheduling the stateful pods. So the scheduler will count up the number of volumes already attached based on the pod spec, and then compare it to this value. If there is space, we assign the stateful pod. So that's kind of like a high-level overview of the issue. The way that this manifests for users is that their pods end up in a container creating state, and it gets stuck. In this state, it requires manual intervention to fix it. And unfortunately, it's actually quite ugly as well, because simply removing the pod is not enough to fix it, because it's possible for the scheduler to make the same mistake, right? So typically what users do is they'll cordon the node, delete the CSI node object, re-register the plugin, and then at that point, right, the issue is sort of fixed, because that's how people update this allocatable property today. So it's quite an ugly failure mode, and the way that certain CSI drivers are working around this today, like Azure, GCP, and the EBS CSI driver, is that they have a parameter to reserve slots. So in node get info, right, we subtract whatever value is hard-coded, but this is really not a great solution for customers, because it's hard to know in advance. And in addition to this, you can never claim back those slots, right? So their nodes are heavily underutilized. So that's basically at a high level what this cap is trying to propose. There is a discussion with a recording with SIG storage where we went over this and sort of brainstormed, and then like this cap is basically the result of that discussion and the solution that we're trying to propose. So at a high level, some of the changes that we're proposing, and we'll go over this with the API machinery folks, but right, as I mentioned, this CSI node allocatable property is immutable today, so we want to make that mutable. And once that is done, we do want to be able to update the CSI node property. And just so relevant here, and this is, we'd love to get your input, right? So as part of pod construction in Kubelet, today we block on waiting for attach and mount. So one of the things we want to do, because we consider this an invalid state, is if a pod fails because the attachment fails as a result of no capacity, and this gets reported on the volume attachment object, at that point in time, we want to update the CSI node allocatable property, right, to stop the scheduler from continuing to make this mistake. So, the sort of like the goal is that today in Kubernetes, like this invalid state, as I mentioned, right, users get stuck with container creating on their pods, and we want to improve Kubernetes so that we work towards fixing this invalid state, right? And this is one of the ways that we're doing it. Once we detect this invalid state, we'd love to be able to update the property so that it more accurately reflects the actual state of the world. And in addition to this, we do also want to let cluster operators be able to periodically update the value. So we're proposing that in the CSI driver object, there should be a new field so that they can specify an interval by which they could query the driver's node get info endpoint and also update this value periodically. That will help with claiming back slots. So that's kind of high level overview of the CAB. As I mentioned, we definitely love to get your feedback on this. Right now we're targeting 132, but that's honestly a stretch goal. I think 133 alpha is more realistic, but if we could get somebody to take a look and give some feedback, that would be awesome.
Some immediate, like we don't have too much time. Some immediate feedback is that we have lots of experience with device allocatables, how to mark them unhealthy, how to mark them healthy, all sorts of race conditions happening. So if you can make it as close as possible to what we did for device allocatable, it may be beneficial because we will at least know what problems we need to expect.
Yeah, sounds good. I'm happy to also have like those discussions either offline on the CAP itself. I think that's different, slightly different to those device allocatables that you reference, because the scheduler plugin doesn't rely on that to determine whether there's capacity, right, to schedule the stateful pods. It relies on this CSI node allocatable count, which is different, unfortunately, from that value. But yeah, thank you.
Yeah, and it's a difference. I'm just saying that we had a lot of experience with understanding what the race conditions can be and how we need to deal with that.
Yeah, sounds good.
Okay. We didn't get to last topic, Peter. Is it something you want to mention really fast, or we can postpone?
Yeah, I mean it is fast. It's mostly just there's a couple of enhancements that that we opted into a little bit later, and they don't currently have approvers. So if any approvers are on the call or listening, take a look at these. Hopefully get them in. If not, we got them a little late, so it's okay. But that's it.
Okay. Do you want to ping people on a Slack to assign approvers?
Sure. Yeah, I can draft up something. Thank you.
Right.